David Stringer, and this is R-2000, the Better Built House. Over the course of the series, we've been looking at different construction techniques that can be used in the design and building of energy-efficient housing. In the last program, we looked at methods of upgrading conventional single-stud construction. In this program, we're going to look at some double-stud construction techniques. Over the course of the series, we've been showing the 5 key features of the Better Built House. It's been a while since we've looked at them, so here's a quick review.
There are 5 key features that are common to R-2000 and energy-efficient houses alike. Firstly, they have higher levels of insulation than the conventionally built house. Second, the houses are built to control air leakage and be draft-free. Third, because the house is that much tighter, a mechanical ventilation system is needed to provide a controlled and regular supply of fresh air to each room of the house. The fourth feature is the use of efficient heating equipment. And the fifth and final feature is the use of building designs which make use of passive solar heat.
In looking at the design and construction of the walls of energy-efficient houses, we're going to be concentrating on the first 2 of those key features. In other words, improving the amount of insulation and also controlling air leakage. I'm doing okay on the basic principles, but I can't claim to speak builderese. So we have an experienced R-2000 builder, Oliver Drerup, here to keep the builder's perspective on things. Oliver, I think that's your big entrance. Well, maybe not that big.
I'm not much of an actor. What we're going to be doing today is looking at double stud construction, which is really a very different way of approaching the whole problem of building a wall.
Well, most of the things we've been looking at so far have been different.
Well, different, all right, but if you'll remember in the last show, we were looking at upgrading single stud construction, and it's not nearly as strange as this. Perhaps what we ought to do is really review what we went over.
Single stud construction can be upgraded without major alterations to conventional construction practices. Improvements to the energy performance of the house walls can be achieved by reducing thermal bridging from the inside to the outside, by properly installing insulation into the wall cavities, by installing insulated exterior sheeting, and by installing a continuous air barrier throughout the house. Some of the techniques for reducing thermal bridging include using single top plates, spacing studs at 24-inch centers, and using 2 stud corners. Insulation levels and performance can be easily upgraded through the use of 2x6 framing, allowing for R20 batt insulation, and by ensuring that the insulation is installed in a manner which reduces air movement inside of the cavities. The use of insulated exterior sheathing further reduces thermal bridging, and when installed to restrict the entry of cooler air into the wall cavities, further improves the performance of the insulation. Finally, the installation of a continuous air barrier can be made easier by pre-planning the detail around header assemblies and interior partitions. Air sealing around electrical outlets and other penetrations can be made easier through the use of manufactured air barrier boxes or by embedding the air barrier into the wall with cross-strapping.
Well, Oliver, as I understand it, we're going to talk about double stud construction. What do you get a load of my first question? It's very basic. What are we talking about?
Well, we're talking about a wall that is composed of 2 walls. We have an interior stud wall and an exterior stud wall. There's a tremendous value in that for 2 specific reasons. One is that it's possible for you to bury the vapor barrier inside the wall so that it gets out of the road of all the tradespeople and that kind of thing. The other thing that's good about it is that you have the opportunity to vary the distance between these 2 walls, and as a result can put in any amount of insulation that you want.
Boy, you're a fast-talking salesman. This sounds great, but it occurs to me that what you're doing here is building 2 houses, one within the other. Is this not a lot of complexity and expense?
Well, it depends on your area. If you're in a particularly cold area, this is actually a very justified system, and it's possible to do a very cost-effective job of insulating a building at high levels by using this kind of approach. The final decision will be made depending on who the builder is. I think we've already discussed that, and the point is that if the builder feels that it's a justified system in his particular area, his crews can adapt to it, it's a pretty good unit.
There are 2 approaches to double stud construction. The prairie approach involves a system where the interior wall is load-bearing. The double wall is pre-assembled and then lifted into place all at once. The other alternative more closely resembles conventional construction, where the interior wall is added after the house has been framed in a conventional manner.
Okay, David, what we've got here is double stud construction, and in this particular instance we have what's called the prairie approach, which means that the interior and the exterior walls are held apart by gusset plates of plywood at the top and bottom of the wall. Reading through the wall from the outside, we have a fiberboard cover. We have a 2x4 that has R-12 in it. We've got R-20 lying in between the two walls. We have the vapor barrier running continuously on the outside of the interior wall. And then we have the interior wall, which will get another R-12. Fully 2/3 of the insulation on the exterior, 1/3 on the interior, and the total assembly of the wall is R-44.
And it seems neat that the vapor barrier is against this piece of aspenite so that the electrics and all that stuff are no problem.
When the tradespeople come into this building, what they're going to see is what they're familiar with.
This is great. I would have really liked to be here to see them put this together.
Well, thanks to the magic of television, we can.
Well, the time machine worked. We've gone from finished wall to a bunch of sticks on the floor, and I'm standing in the door, I guess.
You're in the door of a really conventionally framed wall. Nothing unusual about it. First thing that happens is that we start with a wall down on the floor, built the way you normally would build a wall. Next thing that happens is the poly goes on over the whole affair, and then we're going to put down on top of that a sheathing material.
Okay, where's my hammer? Let's start.
I think we better get out of this picture. They're going to need some room.
Yeah, too. Wow, close, Brian.
They build things up quickly. So that's our old wall under there, and there's a kind of conventional 2x4 wall up here.
In this case, we're looking at a conventional 2x4 on the exterior wall. Often builders will build this outside wall out of 2x3s on 2-foot centers and make it much lighter. All it has to do is simply carry the siding. This is the original wall that we were looking at before. What's been done is a piece of poly has been run across the entire wall covered with aspenite. The purpose of the aspenite is to sandwich the poly between the studs and the back side of the sheathing, and also to enable the builder to build this wall right down here so that he doesn't rip the poly. Then this wall is lifted up and separated from the previous one with this piece of plywood.
Is this a critical space?
You can get any R value you want out of a double stud wall, which is the beauty of it. But usually this winds up being about 1 foot because 4x8 sheets of plywood very economically rip into 1-foot strips.
That makes sense. How do you fit the insulation into this cavity?
Well, if we get out of the road, I think you're just about to find out. The first thing we're going to do is take an R-20 bat and install it horizontally between these two walls because we want to completely suppress any convection currents. We're going to cut the bats very carefully because we want to be sure that all the cavities are filled and filled very carefully. The first layer being woven horizontally, the second layer being laid vertically. We now take an R-12 bat and put it in the outside wall in between the studs. Now, because the racking strength is already taken care of, the crew can put on an inexpensive exterior sheathing just to protect the insulation from any damage as a result of rain, and then the whole wall can be lifted up into place. Now, what we're able to see here, David, is the end of one section of the wall. There'll be another section of the wall coming in here, and the continuity in the air vapor barrier will be achieved on the side of the studs as the barrier turns in. The other thing I wanted to point out to you is that this exterior wall is actually hanging off the platform. So all the load is being taken down the inside wall, through this platform, and down to the foundation.
Well, now, wait a minute, Oliver. That all sounds like a great theory, but this is all wood. It's all connected together. How do you make sure that the exterior wall doesn't get any of the load?
Well, what we're doing is we're taking a 1x4 and laying it all around the top plates at the top of the building before the trusses go on, so that we're ensuring that the weight of the roof will be carried on this interior wall.
In other words, you mean you're making the load-bearing wall just a little taller so that everything has to sit on it?
Right on.
Boy, you can sure talk a lot. You know, at the beginning of the program, we promised them 2 different methods of double stud construction, and now I'm afraid we don't have time to go into detail on the second one.
It's okay, because the second one is really very simple. We've been talking about walls that are interior load-bearing walls with all the additional insulation on the outside. Imagine, if you would, an exterior load-bearing wall, which means that you're essentially building a conventional house and then putting a second wall up on the interior.
That sounds deceptively simple. Is there a catch?
Uh-huh. The problem is that it's very difficult to insinuate the vapor barrier into the wall. What winds up happening is that usually your vapor barrier will be on the inside of the inside wall instead of the outside of the inside wall.
Okay, so it's not hidden, but what causes that problem?
Well, if you're going to insulate between the 2 walls, it means you kind of have to hang the insulation up there and just let it stand in midair while you get ready to put up the interior wall. It's a bit more difficult to do. And there's another problem as well. Imagine the floor joists that are going to go on over our heads here. They are going to now be bearing on the outside wall, which means they're going to penetrate the wall assembly. So it becomes more difficult to get continuity of the air barrier through that whole area.
But see if I'm learning. Could we solve that problem with our friend Tyvek around those headers?
You're learning. The other thing that you can do is to take blocks of blue foam, the SM extruded polystyrene, and cram it up in between the joists to seal that area. But it's a lot of messing around.
Sounds like other things I know about. Sounds simple, but there ain't no free lunch. Uh-oh, you're going to ask me to summarize now, aren't you?
How did you know?
Don't even ask it. Okay, I'll just do it. I think, actually, it's simple. Basically, double stud construction is different, but not necessarily difficult. And there are 2 systems. One is not what the builder's used to, but it really flows together nicely. It's just a piece of cake. The other one that uses all conventional practices ends up causing you some hassles with detailing work. So it's really up to each individual builder and his crews to decide what might work for them.
Always. But there is a point to be made here in favor of double stud construction. If you're looking for high R values in a wall, R40, it's really a very cost-effective way to go about getting them.
Great. You know what? I think we ought to get out of here now.
Where?
That away. Join us at the factory next time.